Welcome back to the Foundation C# course. We are currently in Module 5, and this lesson, we're going to wire up the logic. This is the last step before we have a working application. So let's go ahead and dive right in. Okay, so here we're picking right back up where we left off. Let's actually close out program.cs and player info model. And let's minimize the things we don't have to do because we've already done them. Got a little eager there. So here's the methods that we've created that are not implemented. So let's just tackle these one by one and get the logic down. So player still active. Now the first thing we're going to do is it named it the same as what we had before, which usually works out. But opponent doesn't seem to make sense because this really is just player. Okay? And that doesn't change anything on the calling side. They still pass opponent in, it still works, it's just the naming for this particular method. So how do we determine if a player is still active? So what we can do is say bool is active equals true. We're going to start off at true because we're going to, if anything triggers a false, we're going to set it to false. Okay? So for each, the item in player dot ship locations, and let's call this ship. Okay, so here's how we're going to do this. So we're determining if they're still active, meaning they have at least one ship that is not sunk. So if it's not sunk, so not equal, if it's not sunk, then we can say is active equals true. And this is why you need to think this stuff through and kind of go through, okay, what do we need to figure out here? Because if I checked for sunk, then I'd have to check for all 5 being sunk. But in this case, I can just check for one that's not sunk. Because if any of them is not sunk, the player is still active. Okay? And if none of them are not sunk, then I'll never set this to true. Therefore, it will default to its default value, which is false, which means the player is not active. Now, I kind of violated my rules there. Normally, I call it output. But in this case, is active seemed to be easier to understand going through this part. Therefore, I set it to be is active and not output. So kind of, it's not a hard and fast rule. You can change it. In this case, I changed it because it made more logical sense to call it is active versus output. But with that being said, that method is done. Just a little bit of logic. Let's collapse it and move on to the next one. Get shot count. And let's not pass in winner. Let's call it player, because maybe later on we ask for each person how many shots they've taken. We do have a display the score, and we haven't put that in here. We put our notes to put it in, we haven't put it in. So we'll need to look at that, and that's get the shot count is how we do that. So just player is fine. And what we'll do is we'll start off with the shot count equal to 0. And then we'll do a for each. And we'll say for each shot in player dot shot grid, And we're going to say if shot dot status is not equal to empty, meaning they've either taken a shot and missed or hit. Either way, we're going to say the shot count plus equals 1. Another alternative is plus plus, which would increment it by 1, but this way it's also a valid option. Okay, or we could say equals shot count plus 1. Okay, but this is a pretty standard way of doing things. So that adds 1 to our shot count. And the letter is, that's a great question. The letter is the row. That's a little confusing. We should work on that naming at some point. That's a refactoring we can do, not now, but in the future. Spot number equals column. And the status, notice how at first that list isn't up, the IntelliSense list. What I can do is Control J, and it brings it up for me. I always use IntelliSense because that way I don't have to worry about making sure my casing is correct, because I hit Tab and it fills it in for me. It will make sure the status is empty. Nope. Yes, we'll put ship in the status. So the ship is the status, meaning there's a ship here. It's not sunk. Okay? But notice here that it's returning a Boolean. That's because this place ship will only place the ship if this is a valid location. We just assumed this location was valid. That's not great. So what we need to do is we need to validate bool is valid location equals, let's call it validate grid location. We're going to pass in the model and the row and the column. So what it's going to do is it's going to determine if it's even on the grid. If it's on the grid, that's step 1. Okay, so let's add that method, which that's being put in as a private static Boolean. Whether or not we make it public, for right now, we don't need it public. We can let it be private, but that'll return, yes, it's on the grid, or no, it's not. The next thing we need to do is we need to determine if there's something already there. So next what we'll do is say bool is ship at is spot open equals validate ship location, pass in the model, the row and the column. And what it's going to do, and we'll create this, is it's going to say, it's more about if it was on the right grid spot or not, because we'll check that in another spot. All this is going to do is look at the ships that have already been placed and say, is there already a ship here? And if there's not, then it's a valid location. Otherwise, notice is the spot is open. But if it says, oh, there's already a ship at that location, it's going to say false. The spot is not open. Okay. So now what we can do is let's cut this out. So there's two ways you can go here. I already have code here. I can either Control X and cut it out, or I can right click and say snippet, which is kind of off the screen here, but there's a snippet option and a surround with an if statement. But in this case, it's just easy to cut it. So if is valid location and is spot open, I could say is true, or equals true, but in this case, since I'm not using the bang operator at all, it does still read cleanly, is valid location and is spot open. These are both have to be true in order for us to do this. Okay, I'm going to create an output variable here. Bool output equals false. And right in here, after we place the ship location, I'll set output equals to true. And at the very bottom, I'll return output. Notice I never set output to false after I initialize it. That's because I never set it to true until I actually know it's a valid location and the spot is open and I've placed it. Okay, so now it will either place the ship or it will return false and do nothing. Okay, so that's the place ship method. And now we have to go through and validate the ship location, which what that's going to do is just check to see if there's already a ship at ship dot spot letter. And this is one of those cases where we're using uppercases, but we're not sure the user is. And actually right up here, I believe we place the ship, but with a letter, we really should say to upper. Just to make sure it matches the casing here. And because that might be a bug we find later. So if spot letter, and let's just do equals row to upper, just to make sure we're comparing uppercase to uppercase. And that's done. Now we validate the grid location. So all we're doing in this is we don't even really care about the if it's a ship, if it's a shot, it doesn't matter. We're just looking at the grid itself and saying, is this row and column somewhere in there? And in fact, the logic looks a lot like this. In fact, let's copy this whole thing here and paste it down here. And if you're copying and pasting, you might have a some code that needs to be refactored. But in this case, instead of model.shipLocations, it's model.shotGrid. And all we're doing is checking for, do we find it somewhere? But in this case, we switch this around. Because in the ship location, if we found a match, that meant there's already a ship there. But here, if we find a match, that means that this shot is on the grid, or this ship is on the grid, meaning it said E4, and we found a match to E4. So therefore, it's a valid location. But if we say Z23, that's not valid. Therefore, we're not going to find a match. Therefore, it'll be false by default and never be set to true. Therefore, it's a false location. So that's done. Split shot into row and column. This might be one where you're like, we've never done this before. How do we do this? Don't worry. There's a lot of stuff baked right into the .NET framework that can help us out here. So let's figure out how to split this value into two different values. Remember the arrays we worked with a couple of base separated. That's one option, but it's not the way you want. Instead, we have toArray. And toArray is going to split it apart into its component parts. Basically, we're going to have one entry per character. We can also do toList here, which we like lists. So that's a possibility, but array works, and I think this is the more common way of doing it. So toArray, and it's saying, no, you can't do it because actually it's a char, not a string. So what's a char? Well, a char is one character. I say string row, and let's start off with empty string, and then int column equals 0, and then I'll return both of those at the end. And we'll see how to do that. So row equals shot array at position 0. Okay, now it's yelling at me and saying, you can't do that because a char is not the same thing as a string. But there's this handy method on the end of everything that says toString. And it converts that char to a string. And now it goes easily into row. Cool. One down. Now, that's assuming that the shot array at least has something in it. If we pass in a shot that was an empty string, this would blow up. So what do we do about that? Well, I think the thing we need to do about this is we need to do some error checking and say, let's just make sure that the length is 2 for this. So at the very beginning, we can say if shot.length is not equal to parameter name. So we can say, well, shot was what was out of range. So let's start our message and say this was an invalid shot type, and then pass in shot as our parameter name. That way we're saying, okay, this parameter, that's the one that had a problem, and the problem is an invalid shot type. Okay, so now we know the length is going to be 2. Therefore, I'll have something at position 0 and also something at position 1. Now, if I try to do column, which is an integer, equal to shot array at position 1, that doesn't work. And actually it does. Look at that. But here's the deal. That's not going to work correctly. I'm 99.9% positive, because what if we said AB was our shot? Would that be a valid char? Yes. Would B go into a number? No. What it's doing here, I am almost certain, is every character has a number associated with it. These are ASCII characters, so it has I believe. So it has a ASCII number associated with it. So for example, the enter key, I believe, is 13 is a number. Sometimes 10 and 13 if it's a line return and new line, or it's all confusing sometimes. But the result is, I think it's going to take that character number and put it in our int, and that's not what we want. We want the actual number, which technically comes from the string. So how do we make sure that we get the string value of this? Well, we can say toString, which will fail. But if we assume that this will be a valid number, then we can cast or parse this. So let's okay with that exception. So now we have our row and column. If they do it right, it's going to work. If they don't do it right, it will throw an exception. In either of those cases, if if we get it right, we need to return those values. Otherwise, it's going to exit out improperly, but also close the application. In the next lesson, we'll talk about how to deal with that and make sure that we handle those exceptions when we go through testing. But for now, we're going to pretend like the users don't hate us and try to mess up our application at every step, which sometimes it feels like. They don't hate us. They just do things we don't expect. So, how do we return a tuple? Well, it's very easy. Return, put in parens, the row and the column. Those are the two values. They're going to get mapped to this row and column and get returned. Now we have a working split shot into row and column method. We can close that out. We only have 3 more to go. Validate shot. Well, this looks a lot like actually this code right up here. Kind of like this. And we'll change it around. We're going to say it's not a valid shot. So is valid shot. I do control dot here to rename it. It only renames it here. It does not rename it up here, even though it still says invalid shot location up here. The reason why is because Visual Studio is smart enough, really smart, but it's smart enough to know that the scope of this variable is these curly braces. Therefore, it only changes the variable inside these curly braces. So, and we're going to call this the player, not the model, or not the active player. And we'll say, so in player dot shot grid. So we're going to loop through, grid spot. We'll control dot with that as well and change it. This is why copy and pasting can be dangerous, because you have to rename everything and make sure it's right, and don't compromise on things and check everything. So it can be complex sometimes, but sometimes it saves some time. Just be careful when you're doing it. So validate shot, what it's going to do is it's going to check every spot in the shot grid until it finds the one that matches the row and column. Okay, we got this, the match the row and column. But instead of just saying it's valid then, what we're going to do is when you find that match, and this should be false. When we find the match, we're going to say if grid spot dot status equals empty, then it's a valid shot, because it's we haven't actually because we can't put 23 in, it's too many characters and it'll throw an error. But let's say Z5. We don't have a Z5. So what's going to happen? We're going to look for a match for Z and 5. Are we ever going to find it? No. So we'll loop through the entire shot grid, not find a match, therefore we'll never check this. Therefore, we'll never set is valid shot to true. Therefore, is valid shot will be the default value, which is false. Therefore, it's not a valid shot, which is correct. So this kind of does double duty here, of first checking to see if the shot's on the grid. And if it is on the grid and we find it on the grid, then also checking to make sure that that spot is empty and it's not already been a hit or a miss. Okay? And that's all the logic we need to do for that. Identify shot result. This is where we look at our opponent and say, is there a ship there? And we already kind of have this logic somewhere else. Validate ship location. So if it's a valid location, meaning it's going to check to see if there's already a ship there. Well, that could be something we use, because if a ship is already there, then what I'm going to do is just copy this logic and come down here and paste it and flip it around. Call it is a hit. And we're going to pass in the opponent ship location. And we're going to say that, oops, I didn't rename this. And now I can't. Notice there's no rename there, because now it's separated from these. So now is a hit starts off as false, but if we check the ship location and find a match, then it's a hit. Okay? Now, like I said, I have the same logic in two different places. That's not dry, which is don't repeat yourself. I want to change that. I really do. Not yet. And the reason why not yet is because I haven't gotten through getting this application working yet. It's not the time to optimize my code yet. I'll make a note of this somewhere and say, really want to refactor that. Make it into one method that does both things. But for now, I'm going to leave these. And so what we're going to do is we're going to not ship locations, though. I should have copied a different one, but that's okay. Instead of ship locations, it's the shot grid. And we're going to loop through the shot grid. And if the grid spot, we'll control dot here to rename that. If the grid spot matches, then what we're going to do is say if is a hit, then grid spot dot, grid spot, IntelliSense is going crazy on me. Grid spot dot stat. because I'm modifying the grid spot on the player on their shot grid. And since it's an instance, then I'm using the same house as everybody else. I just have a copy of the address. So we're all good. We don't need to return anything back. Now, our application should be complete. Now, as much as I'd love to hit F5 and start running this, we've broken this apart into different lessons. The next lesson is going to cover testing our application, debugging our application, and working through those issues that come up when you first run an application. Whether it works great, and I hope it does, or whether you have some bugs and quirks that you have to work. The purpose of an application is to run. If you can't accomplish that purpose, it doesn't matter how beautiful your code is, how clean it is, how organized into layers it is, how solid it is, or dry, or all these other acronyms and other stuff that you can apply to it. Doesn't matter. If it doesn't run, it doesn't matter. It's not a good application. Okay? So our first goal is to get a working application. After that, we can make it better. Okay? So while we did do some things where we're like, oh, we can reuse this method in more than one spot, and it made sense and we did it. That's great. Do so whenever you can. But if you come across a situation like we did, where we're like, oh, hey, wait, we've got some similar logic we can probably tweak into being one method. Wait. Just wait. Do the repetition, then come back to it later and make it better. Okay? So that's the pro tip for today. The homework for today is to thoroughly test the application for bugs. This is one of the harder things for people to do, especially newer developers, is to thoroughly test. Because thoroughly testing means you don't say, okay, my ships are A1, B2, C3, D4, and E5. That's 5 valid locations. I'm going to test with things like Z23, see what happens. Okay? If it accepts it, that's a problem. If it crashes the application entirely, maybe that's not ideal. Maybe we do something different with that. Okay? So we're going to try these different things. I'm going to try things like, what if I don't give it any location? What if I give it the same location 5 times? What if I do something where I give it a negative number? What happens? Or, just trying different things. Because while it's tempting and it's easy to do what you expect to happen, and you should test that, the harder thing to remember to test for is the unexpected. And trust me, your users will find a way to mess your application up badly if you haven't planned for the unexpected. So, thoroughly test the application for bugs. Try to break it in various ways, and then identify ways to fix it if you find a way to break it. So if it breaks when you put Z23 in, what are you going to do to fix it? Try and figure it out, okay? At the very least, document all the different ways it breaks, okay? And then in the next lesson, we're going to do the same thing, and we'll see how you did.